the last lesson I did for the tutors, or for you guys, my tutors, I did resistors, where I spoke about a few things, and then there's some circuit and take a card. I spoke about diode allowing current to flow in one direction. Also did a circuit with a button. Today we're going to look at the slide switch. Is it slide switch? Yeah, slide switch, potentiometer, and photoresistor. So let's get into it. So slide switch, let's use a blank slide switch. So as I said earlier, it's important that your student knows the source of the source. So you'd want him to do some search of what is a slide switch, have an idea how it looks like, a real one looks like, and then go into Tinkercad and see what exactly you're going to use. So we're going to, though I'm going to show you how to use it, we'll also experiment in a few ways. So a slide switch is kind of like a button in a way, but instead of pushing like a push button, you slide to close the circuit. So it's basically a key to close the circuit. So we're going to start with simple. So over here, basically what happens is that this is like a metal strip. So I'll have to do the circuit if I can simulate it. So let me bring a resistor here, then let me bring a battery or something here. This is huge, but it will do. So let's put some of everything to look straight. Okay, so we have a battery here. We have resistor here, and then we have LED here. Okay, so I'll change this to usual 330 ohms. Okay, booyah. So now basically it's, as I said, it's just like a normal switch, like switch that you just flip, a toggle switch, a button, whatever. So if I should run simulation, this is still off because these two terminals are not connected. These two terminals are not connected. Now this terminal will usually be, I think, common. Basically common kind of means a couple of things. One, you can assign in anything to it. Two, so it's used in different cases. One means that you can assign a terminal to it. Two means that it's a ground. You get me? So okay, so let's go. I turn on, get me, and it turns on. So it acts as a way of connecting these two terminals together, right? Okay, so now I've done this. What if, watch this, what if I put another resistor here, so that we can understand some things. I'm going to put another resistor here, and then let's take another LED. We'll turn this green just so that we get some variations. I'm going to just color code everything so that everything is seen properly. So make this red. Make this so red. Make this so red. It's black. Okay, I can see the positive and negative side properly. And let's turn this to green. Voila. Okay, now let's run the simulation. Okay, so still this is still off. When we do this turns on. Now why? Because if you watch, the positive side is connected to this terminal. Now when we slide the switch will connect this terminal to this terminal. This terminal is still off, right? Okay, so a few things that can happen is, let me stop this. Oh, sorry. now, voila. So a few things that can happen. I connected this terminal to this terminal, which means that once I turn the battery on, this terminal is automatically connected to this terminal. And if the switch, the slide is on this, it means that this terminal is also connected to this terminal. Remember, this is like a metallic strip that connects whichever side, whichever two terminals it falls in between. It connects those sides. So automatically, if I create a wire from here to here and I turn it on, this is already kind of connected, hence this will turn on. This slide is here, hence this will also turn on. So these are just some ways you can play around with it. So now if I slide the switch, that this goes off, but this still stays on. Awesome. So there are different, you can use it in different ways. You can combine sliders and get different effects with it. So now you know how the slide switch works. Let's quickly go to the potentiometer. And as I said, once again, you like the student to do some research on it, and you also need to know more about what you're going to teach on. So we're going straight to the potentiometer. To do the potentiometer, let's just clear the stuff so that we don't get confused in any way. So clearing, I'll leave this one. Yeah. So we're picking up the potentiometer. Now the potentiometer is also a sleek one. It's a sleek one in the sense that we have this terminal, so see this terminal 1, terminal 2, depending on which side you want to. So you assign one to positive, to the voltage, and the other to ground. Then the wiper is kind of like what varies the resistance, and in varying the resistance, it varies the amount of voltage and the amount of current. So that's what you connect to the LED. So let's quickly do that. I hope I can align it in a nice way. If I can't, pardon me. So I'm coming. I want it to look nice. I really want this to look nice. So let me just turn this. Okay. Let me put this here so that I can get some. Nah, this won't work. Let me turn this. Yeah. I think this should probably suffice. Okay. So let's do this. You don't have to arrange it the way I'm arranging it. I'm just worrisome. Honestly, there's nothing to it. There's honestly nothing to it. So this will go here. So I'm connecting positive and negative, right? So I've connected. Then now I need to connect my slider, my wiper. Sorry. Slider is from the slide switch. This is your wiper. So then I'm connecting my wiper to ground. Hope you are seeing. You don't really have to move your things around like this. You can just simple. Positive is going to one terminal. The other terminal comes to negative. Down. You're done. Then the wiper goes to the positive side of the LED or whatever you are controlling. It could be a motor. Goes to the positive side of that. Then the anode, then the cathode, that negative side, also comes to ground. So I think we've done it pretty well. Oh, what to add a resistor? Let's add a resistor. Let's add a resistor. where is my rotate? Sorry, I honestly forgot about the low resistance of that. Okay, okay, so starting simulation. Okay, so you saw it. Let me reduce the resistance so that probably we can get the thing being brighter early. Okay. Okay. So yeah, so as you increase the slider, so the resistance. So when you start, this is the entire resistance. So if you Google and you search for the potentiometer, you see that the wiper is like a strip, a resistance strip. So currently the current is facing a large resistance. So as you increase, you are reducing the length of the resistor, hence decreasing the resistance, hence the current becomes more, hence the brightness begins to show, and more and more and more and more and more. So you have it very bright. Okay, so yeah, that's how the potentiometer works. My work is just I just like to keep things neat. That's why you see all the squares, and usually too I'll turn this red, turn this red, turn this black, turn this black, just so that I'm comfortable knowing that I'm using the right conventions at the point in time. So do some reading on the potentiometer, and yeah, I know that the potentiometer serves two purposes. When you read, you would see it. So can you do the reading? And just simulate it one more time. This is well lit already. I can just drop brightness. From here, it practically looks like it's gone off because the current is. And when you're taking that to be slow, because the simulation takes time to really show the light well. So if you slide like this, you think nothing is happening. Slide it very fast. So yeah. So we are done with the potentiometer. Now let's go to one of my favorites, which is the photoresistor. We also have to look at the ultrasonic sensor and all that, but I think that the photoresistor has a lot of things to involves a lot, so I'll end with the photoresistor because I think time or the video will be very long. So the photoresistor, what we're coming to do with the photoresistor is we're not going to write much code. We're just going to come to see basically how the photoresistor works, how to read values from the photoresistor. So once again, you'd want to do some research on the photoresistor with your students. You want your students to actually do some research photoresistor, how the photoresistor work, what is it at all. I mean, it's like a potentiometer because it also varies resistance, due to the amount of light falling on it. So your students should have an idea, should be able to do some research, vertical and horizontal research, and see what he or she is really coming to do. Over here, I'm just coming to show you how to do a simple connection and read your values from the photoresistor. So let's find our photoresistor first of all. Bam, this is it. Connect our photoresistor, then we get our actual then we get our actual resistor, which I'm gonna flip as usual. Bam. I'm gonna keep it at 1K. So remember that anytime you're using something like a sensor or anything that has to detect something, you always have to power it, right? So we're going to power we're going to give it power, a 5 volt power. That's what we're going to give to the resistor. That's what you see over here. So the power will flow through here, and then over here we're going to ground it as usual. as usual. Then this is where we read how much current is flowing through it, which is directly proportional to how much light is falling on it. So if you do some reading, if you know how the photoresistor works, you understand, because how much light is falling on it is directly proportional to how much current is flowing. The more light falls on it, the less the resistance, hence the more the current. By convention, I'll turn this to red and turn this to black. Voila, I'll leave this as green. So we're practically done with the setup. Let's go to the code. Now your student should actually be able to write the code in syntax. Sorry, this is so wrong. Write the code in syntax. But for the purpose of the fact that this lesson is more about the photoresistor than programming it, let's quickly do it with code blocks. And then, so when you are doing this, focus on the connection first of all, and then you can come back later and then focus on the code. You get me? So focusing on the connection, you can just do it with code blocks. So we are going to print to our serial monitor whatever we are reading from our analog pin. Now you see analog pin here. Why are we using analog? So this is A0, A1, A2, A3, A4, A5. They are all analog pins. Why are we using analog pin? This is because the values we are going to read are not on and off values. It's not on and off signals. We are directly reading a range of values. So starting from 0 to whichever number. Since it's not a digital value, maybe 1, 0, on, off, high, low. Hence we need an analog pin to read analog values. So here we are telling it to read the analog value from pin 0, from pin A0, and then we are telling it to print this into our serial monitor. So if we start our simulation here, we can open our serial monitor, and then we're seeing the value here. That's how much light. If we increase the amount of light in the room by simulating this, we see that the amount of light showing here is like way more. Now if we change this, let's stop and let's look at how the code is, and we'll come back and like write the code actually in another lesson. So if you look at it here, you would identify that the pin mode A0 is no longer what an output, because it's not giving signal, it's rather receiving signal. And as usual, serial.begin to start, and then what we did was serial.println analog read. We are printing the analog reading of A0. Delay can be changed at any point in time. So that is it for well, the student should be able to do this, understand how the photoresistor works, and then on we go. Thank you very much for watching this lesson. I'll see you in the next lesson.